Hello guys, welcome to our presentation. The topic of interest is Cauchy-Riemann equation, and we are going to do the application part of the Cauchy-Riemann equation using a question that is before us. And this question reads, using Cauchy-Riemann equation, show that the complex function is not analytic at any point. And the complex function is f of p is equals to 2p squared plus k plus I into bracket k squared plus p. This is a complex function. Remember, it has got the real part and the imaginary part. So let us solve this question. Solution. We need to remember that the Cauchy-Riemann equation says that when you find the derivative of u, let's say this is the first function with respect to x, this one should give you the same thing when you find the derivative of another function v with respect to y, or again you can say when you find the derivative of u with respect to y, this one should give you the negative derivative of the second function with respect to x. So if the criteria is met, if this condition is met, then we say the function is analytic. If they are contrary, then we say that this function is not analytic. So let us begin. The function is f of p is equals to, in fact, 2p squared then plus k plus I into bracket k squared plus p. So we let u be 2p squared plus k. This is u. And then let v to be the imaginary part, which is k squared plus p. So this is the first equation, and then this is the second equation. So we want to differentiate the first equation with respect to p. Let us differentiate the first equation with respect to p. So let's have the first equation with respect to p. Instead of x now here, remember we have p. So we are differentiating with respect to p. So when you differentiate the first equation with respect to p, you will in fact get 4p. We all know that when you differentiate a constant, it will give you a 0. So we have 4p. We also want to differentiate the second equation with respect to the second equation with respect to, instead of now p, we are going to differentiate with respect to k. We differentiate with respect to k. When we differentiate with respect to k, in fact, we are going to get 2k. We want to proceed and differentiate. Differentiate the first function with respect to k now, with respect to k. In the first case, we differentiated with respect to p. Now we differentiate with respect to k, and the answer is 1. Let us also differentiate the second function with respect to p. This one will give us what? It will also give us 1. It will also give us 1. It will give us 1. It will give us 1. So that is what we have. So let us check whether the criteria is met for this function to qualify to be called analytic. Let's see whether the derivative of u with respect to p is in fact equivalent to the derivative of v with respect to k. When we check this, you will find out that the derivative of u with respect to p is in fact 4p, and that one of v with respect to k is 2k. Let us check the other one. The derivative of u with respect to k being equivalent to the negative derivative of v with respect to p. Let's check whether this one will give us the same thing. So this one is 1, which is equivalent to 1. As you can see, this one is a negative and this one is a positive, but all of them are positives. And when we check this one, this is 4p and this one is 2k. So they are not the same. So we conclude by saying that the function f of p is not analytic, at any point, is not analytic at any point. Thank you so much for watching. Continue subscribing and sharing this video. Thank you so much.